Hi, and welcome to our project. This is a movie recommendation system by Marina, Ty, and Joe. So, for the introduction, the relevance is in today's digital age, movie consumption has skyrocketed with popular streaming platforms such as Netflix and Hulu. Personalizing movie recommendations is highly valuable not only to the users, but also the companies. A well-designed movie recommendation system can enhance user experience, drive user engagement on the platform, and increase platform loyalty. So we thought this would be an interesting and fun project to do, and that's what we're doing. So our contribution for this is in traditional recommendation systems, they use what's called collaborative filtering. Uh, Streaming platforms use this to utilize the collective behavior of all users and make recommendations based off of it. There's two different types of collaborative filtering. There's user-based collaborative filtering, which is where users who share similar interests, uh, movies are recommended to them based off of it. And there's item-based, which is essentially where find movies that are similar to what users have interacted with, and it recommends based off those. Our deep learning model is different to those systems because we use content-based filtering, and by doing so, we're enhancing personalization. This approach recommends movies based on similar features in movies they've previously watched, such as like the genre, the actors, the budget of the film. For individual users, this can provide flexibility in data and show them more movies they might enjoy. So for our data set, we found it on Kaggle. It had 270,000 users with 45,000 movies and 26 million ratings. Our laptops couldn't really process this much, so we had to shrink it down exponentially, and we used 700 users and 9,000 movies. For the data cleaning of the set, I combined all the tables into one CSV file using R, and I removed most of the irrelevant information we didn't plan on using, like it gave us poster pictures and other IMDb things. We also just limited it to American English movies only. I also added a column in the data set that's called liked movie, where if the user rated the movie 3.5 or higher, it was marked as 1 for they liked it. And if it was lower, they'd mark it as 0. The cleaning continued throughout our development. Depending on what we needed and what we didn't need, we would add and remove stuff from our CSV file as we saw, please.
Okay, when we were looking at our data set, we thought it would be helpful to do some visualization. So in R, I was able to create this bar graph, which takes the ratings, which were one of the columns in our CSV file, and it shows us the frequency of each rating. So from here, you can see that our ratings had a range from 0 to 5, and then the frequencies had a range from 0 to over 10,000. So you can see that 4 was the most frequent rating, and the least frequent was 0.
All right, so for our method, we used four different attributes in the data set. We used overview, so that's basically a description of the particular movie. We used genre, which is just the genres that are included in the movie. Note that for genre, the movie can have multiple genres. The budget, so how much, well, so that would be the budget of the movie, and then the title. And basically, for overview and title, I tokenized, well, so we tokenized the those attributes, and then for genre and budget, they're one-hot encoded. And for both overview and title, since they're strings, I created a embedding for both overview and title, while overview is word embedded and then title is character embedded. And then following that, I have an LSTM layer for both of them. And then for each layer after that, I concatenate them and then create two dense layers. And for the final dense layer, that's the final output. So for actually testing the accuracy of the model, we use cross-fold validation, And basically how that works is for each iteration, and for my example, this is a 10 k-fold cross-validation. You set the test to a particular chunk. So, for example, this would be the test and everything else would be train. You would train on the train part and then test on the test part, and then you would capture the accuracy, and you would do this k many times. So in that case, it would be 10, and then you would get the average or the mean accuracy. And why we did this was because since, if you think about it, since users might watch only a few amount of movies, there's not very much observations, so the accuracy can kind of be sporadic. So this kind of helps give a more accurate accuracy. And so this is the results of our model. Note that this is using a user that had 564 movies rated. So and basically our accuracy was 80%. And then comparatively to collaborative filtering, this was the paper on collaborative filtering. They got a accuracy of 70%, and for on their other data set, they got an accuracy of 87%.
Okay, so now it's time for a little discussion. Due to time constraints, we couldn't develop our system as much as we wanted to. So ideally, we would have been able to test our results with collaborative filtering as well as content-based filtering. Because according to a paper that is listed in our references, the best accuracy when using collaborative filtering was 70%, which is pretty high. So our next steps would be to test out different types of filtering methods, including collaborative, to see which one yields the most accurate results. So now on to our project management. So we decided to split up the work based on our strengths. So Ty has experience using deep learning methods, so he contributed his expertise in that area. Joe has experience cleaning data in R, so he cleaned our data set to the specifications that we needed. As he already talked about, he originally removed some of the extraneous information that we didn't need, as we continued along with the project, we realized more information that we could remove to make our jobs easier. And then I performed the visualization in R and organized the proposal and final report so that we had clear goals and a precise conclusion. Because when we were first starting out, we didn't really know what our goals were, so that was really an issue when we were trying to figure out the implementation of our project. Overall, we worked as a team to make sure our project was completed to the best of our abilities, and we all learned something we didn't know previously. For example, I had never coded in R before, so this kind of gave me some insight on how to use R to visualize a data set, which I'm sure that I will use again. In conclusion, after creating our own system using content-based filtering, we can now appreciate the benefits and drawbacks of each filtering style. So as we already talked about, a lot of the bigger companies use a collaborative filtering, which we can now see why they would do that, because we previously mentioned that content-based filtering allows recommendations to be more personal, but it doesn't allow us to group users and utilize data to its fullest. So collaborative filtering most likely would have been more accurate and more helpful to group the users and use all of the data, but as I already said, we didn't have time to test this theory. So doing this project allowed us to see that using collaborative-based filtering is the best method for these bigger companies. But for us, content-based filtering was more realistic with our time constraints.
All right, so this will be the code demo. So if I go to GitHub, all right, so this is basically some of the functions we used. So this user movies basically just gets the list of movies for each user, gets the important columns. So and also converts it to a NumPy data frame. Then this pattern to list, one of our attributes specifically, like for example, the genre attribute, those for some reason are in JSON format inside of the column. So basically, we just use regular expressions to extract the important values from it. One hot encode, which is pretty self-explanatory, just creates a one hot encoding matrix based on a dictionary. And this is just for data splitting. So if we were not to use k-fold validation, we would split it based on a ratio. Generate sequences basically tokenizes it tokenizes text data, and this is used for specifically for the ones that are going to be turned into embedding vectors. This pre-process function basically does all the pre-processing, so gets the individual important attributes, and then does the pre-processing to those attributes, and finally returns them. And then this is the k-fold. Basically, it's just going through each fold, and it's going to run the model. And I'm not using, I'm using their TensorFlow for constructing the model. And then compiles it, fits the model, and then creates predictions. And that is about it. Okay, and then this is basically our references. So it was just neural collaborative filtering, Kaggle dataset, and a guide of getting started with movie recommendations. And then this is our data set. So this will be, you can access it through GitHub, either through the link or the QR code.